So yes, thank you for the invitation and to give a talk in memory of Eric. As you said, I will talk about Holocene vegetation across Europe, and this is a common talk with Marie-José Gaillard and Ralph Fife, and many of the collaborators that are here today, and through different projects that you can see here. So over the last 10 years, in fact, we've been working on this. So I will show you why we did this and in which purposes. So the incorporation of land cover in climate model is still one of the major priorities in the climate modeling community. In particular, the anthropogenic land cover change is still not successfully implemented in these models. Therefore, the effect of anthropogenic forcing, such as burning or deforestation on the climate via the two main biochemical and biogeophysical processes in the past, but also in the future, is not fully understood yet. So the problem of climate models to cope with anthropogenic land cover is due to the fact that the dynamic vegetation models that are coupled with climate models, they are simulating climate-induced vegetation, but basically what we can call potential natural vegetation, but they cannot simulate anthropogenic vegetation. So what we have at hand was different scenarios of anthropogenic land cover. As you can see here, 3 of them has presented and been reviewed here. So one is the Kakaten scenarios here. Here is the well-known Hyder 3.1 scenarios, and here the Elofsson and Hickler. And this is a map of fraction of grid cell under natural vegetation at the early Iron Age period. And what you can see is how it shows large discrepancies in terms of the surface that are in red and in light green, which is in fact the effect of human impact on the vegetation. So this needs to be improved and implemented. And how can we do this? One way to do this is to use independent paleoecological data, such as pollen, to infer past land cover change over large scale. And this was one of the objectives, and this is still one of the objectives of the project Land Claims and the Pages Land Cover 6K. More recently, there is another EU project that is also looking at climate, but mainly focusing on one of the work packages is mainly focusing on the cultural landscape over the Holocene through this concept of energy regimes. So basically how humans have exploited their resources over time and how this has resulted of shaping different landscape and therefore different biodiversity in terms of plants, but also in animals. And this data will be further used by the other work packages that is looking at producing scenarios of landscape change in the future. So when I speak about pollen-based land cover reconstruction, I mainly speak about 3 generations of maps we have created over the last 10 years. The first generation was the one produced by Land Claim 1 that was using 600 pollen records over the Northern Europe, focusing on 5 time windows that were relevant for climate modeling and mainly 25 taxa. This has been published and the results are stored in Pangea, in the Pangea database. The second generation is soon submitted from the Land Claim 2 project, and this is now looking at all Europe with more than 1,000 pollen records, focusing now on all the Holocene at 25 time window of 500 time resolution and working with 31 taxa. And the third generation that is underway with the Terra Nova project is to increase the number of pollen sites in southern countries. So how do we do to convert pollen percentages into vegetation percentage? And this, we are using the REVEALS model that has been published by Shinya Sugita some years ago. And for this project, I'm talking about, we are using all pollen records that are available and suitable in terms of HDEF modeling within a 1 by 1 degree cell, which corresponds to 100 by 100 kilometers. This is the scale for reveals reconstruction, but it's also the scale that is relevant for climate modeling. So we are using the reveals model, and as an input, we have relative pollen productivity and fall speed for key taxon that were available at the time when this different project started. So what will the reveals produce is the percentage of plant cover, their standard errors for individual taxa, so 25 to 46 taxa, that are further grouped into plant functional type and then further grouped in land cover type. And I will mainly speak about open land, broadleaf, and conifer land cover type. This is to show you for the third generation we're working with now, the distribution of the pollen sites across Europe. The light green sites are the one we got from the Landclean project, and the red ones are the one we recently collected for the Ternera project. All together, they cover more than 500 grid cells across Europe, and some grid cells will be revisited from the second generation of map, and some will be completely new, the purple one. What I wanted to stress here that for the new sites, most, if almost not all, the data are coming from the EPD and the Neotoma database. So now I wanted to just show you some of the results we got from the different projects. This is the reveals estimates of past open land for 5-time window. Here you can see the scale of the color. The darker, the more open it is. And you can see how the landscape is gradually becoming more and more open from 6,000 cal-BP to the modern time window, reaching up to 20 to 40% of openness already at 3,000 cal-BP, with a maximum openness at 200 cal-BP. This data then can be used in a different way. As you have understood and seen, we have value for grid cells. And what the Landclean project did was to create continuous maps of past land cover based on these grid cells to basically fill the gap between the grid cells. And I will show you an example for the modern time. So you have here the 3 land cover types, the scale here of the percentage. And how they did to fill the gap, they used independent data, so that the climate-induced vegetation, the LPGS, but coupled with the KK10 scenario of deforested land. And they use different models, spatial statistical model, to create continuous maps, as you can see here. This has been then compared with observed modern data from the European Forest Institute. And what you can see here is that the observed data are quite close to this map produced with this model. This has been done for the 5-time window. We've been working for the Landclean one, and it's currently underway for the 25-time window for the Holocene and for all Europe. Then I wanted to stress here, it's that to show how the climate models are sensitive to the vegetation data that are used to feed the models. And I'm focusing here on the winter and summer temperature at 200 cal-BP. What you can see here it's the winter and the summer temperature that is simulated when they use potential vegetation as an input. And here it's the difference, a map of differences of temperature when we use the HIDA compared to the potential vegetation, and when we use the KK10 scenario compared to the potential vegetation. And what you can see here that we get lower temperature by -1 to -1.5 in Eastern Europe due to the effect of deforestation. And for the summer temperature, we have higher temperature by up to +1 degree in many parts of Eastern Europe and -1.2 degree around the Mediterranean area. So this is showing basically that, yes, it does matter what is used as an input vegetation data for the climate models, and that the anthropogenic or human impact is very important to consider if we want to fine-tune climate models. This is a short, I will show you a short video about the last generation of maps we got so far. So we got it like a couple of days ago. It is open land, and you will see the degree of openness changing through time for 25 time window. And we will start from the beginning of the early Holocene to the modern time. You have here the scale again, so the darker, the more open it is. I'm not going to interpret the results because this is, as you have understood, quite new, but I wanted to share this video to all of you. So like it's a way, a bit like similar with Thomas, that's Giseke that showed it a few minutes ago. But this is now the revealed reconstruction. So basically a percentage of open within 1 by 1 degree cell. And you will see how it has changed through times, how it was less open and when it started to be more and more open at this time window, for example, especially in the western part of Europe. Yes. And then my final slide will show you the largest synthesis of reveals estimate we got so far for the Northern Hemisphere. This has been published some years ago, published for 3 time windows. Here you can see at 200 cal BP, published for 3 land cover types. Here it's the open land, and you can see how open it was at 200 cal BP. As you have understood, now we are at the stage where we have much more data for Europe, especially all Europe now, Northern and Southern Europe. Some more results have been published for temperate China. Some are recently published in Africa, in Cameroon especially. And I wanted to finish here by saying that all of this work have been possible because we've been using pollen database across the world, and that would not been possible without the help of Eric, that has been initiated different pollen database, encourage us to use this. So I wanted to finish by thanking Eric once more and showing some nice pictures of him. I think was maybe the last time I met him in Tartu in Estonia. So thank you for listening, and thanks again to Eric for all his work and to help us among the last 10 years, in fact, and to give us to the new generation this possibility to use pollen database. Thank you.